Okay, we're going to finish talking about how to use fork, and we're back at our forks page, right? So if you were to Google fork and go to linux.die, it's a great website for talking about different system commands. So if we go down, we talk a little bit about fork right here for the return value. It says, on success, the PID of the child process is returned, and it also returns 0, right, when it is the child process. So, because remember, it returns twice. And also, it can also fail, right? So this is important to understand because as you're programming, you always want to make sure your code doesn't just randomly break, right? You want there to be kind of error messages and also checking for, certain bad return values. So with this in mind, let's kind of rewrite how we would usually use. Okay, so here we have int main, right? Let's not forget. And okay, here we have our main code. Let's make this slightly bigger. Let's see if I can bring it up. No ideas if you guys can see this. Okay, so here we have our main function. Now, when you're trying to save the value, there are certain data types made specifically for kind of this kind of programming. And one is called PID underscore T. So you can kind of think of it as kind of just an int, but it's specifically made for capturing the return values. It's like because it holds certain limits of what fork can return, right? So this will be child, right, process ID, so child PID, or, right, don't forget, or it could be, let's see, or it can be 0, right? Because fork returns twice. So if child PID or 0, right, is less than 0, that we know this was an error. So what we should do is we should print an error message. And in systems level programming, there's many unique functions kind of just for systems level programming. And one is called perr. Now, of course, you could always use, kind of printf, fprintf, but it's probably best to use kind of perr. And you can look this up on the linux.die website as well. So, fork error right here. And when there's an error, you want to exit. And you want to use exit, and you want to put a negative number to represent, basically, usually -1 to represent something bad happened, right? If you exit 0, that kind of means something, like everything's fine, now you can exit, right? So if that's the case, we want to exit. Now, otherwise, I mean, that means this child PID or 0 is fine, right? Because only when it's not this is it bad. So if this is not equal to 0, then we know we are in the parent process, right? Because it's 0 when it's the parent process. Return 0, that means we're in the child process, sorry. So if it's not 0, that means we're in the parent process. So I can write like printf, hey, I'm the parent, right? And remember, if you remember, each process has a PID, right? So the parent has a PID, and the child, so my child is also a PID, right? So I can say the first one for the %d, for the parent, I'm going to say get PID. And that gives me the PID of the current process, which is the parent, since I'm in the parent process. And when I want to write the PID of the child, it's going to be the child PID 0 right here. Because when I'm in the parent process, this variable right here, right, becomes the PID of the child. Now, that was basically when I'm in the parent process, right? Now, else, we know from the last video, right, we learned that, oh, I'm the child process, right, with this number. So what happens if you didn't realize is that what happens right here is that this gets replaced by getPID, and this %d gets replaced by child PID or 0. Okay, if I didn't make that clear, sorry. So I'm the child, right? My parent is %d, boom, boom, boom. So in this case, it's going to be getPID, which is the child's PID in this case, right? And then how am I going to get the parent's PID? Well, I can call special function. What would happen? And it's called getP, standing for parent PID. So all these Unix functions, right? The people that create these functions were super lazy and did not want to name everything full out. but if you can kind of Google them and learn about a lot. So I'm going to just kind of giving you a brief introduction to a few of them. So otherwise, I can print this. Now, other stuff you can do is that when you're in the child, usually that's when you want to kind of execute some main code, for example, right? So there's other functions that are pretty interesting. For example, there's one called execl. Now, what basically exec. What exec does is it can execute basically an executable in the current process. So one example of how to use this, there's many different of these types of functions, but one example is, I can access the echo function. So if you're not familiar, here we are back with our command line, and if you're not familiar with echo, you can say stuff like, all you can do is like, I love, Taylor Swift, right? And what it does is it just prints it out. That's all it does, okay? Okay, so we're back in our code, back in the thick of it, and I'm going to basically say, hey, I'm going to execute this echo thing, right? And I want it to print hello world. And now these other parameters, you can look at the doc and you can kind of pass them in, but that's not really important. But what I'm trying to demonstrate is that usually in the child process is where you kind of show, where you write a lot of your kind of code for doing the main logic, what you want to do. And then what you want to do inside your parent process is you want to wait, right? Now it's very important to wait because what if your child process never ends, right? Or what if your parent finishes first, right? And your child process is still running, and then a lot of resources can be wasted. So what you want to actually do is you want to call a function known as wait. Okay? You're going to pass a null, and what this does is it waits for the child process to join with the parent, with this parent. Okay? So once the child process is done, it joins the parent process. Okay, very cool. So we can't forget to return main, or return 0, sorry, return from main. And now let's see how this code executes on an actual machine, right, on an actual Linux machine. So here we have the command line again. Right, we have the Taylor Swift thing. If I ls right here, I can write cat, let's look inside. I'm going to use Emacs, which is a text editor for Linux. And I'm going to look through this file. So here we have all the include statements for all the different functions we're calling, right? When we call exit, when we call wait. Now, here we have our main function, right? This is just kind of, we don't actually use this, but this is the argument count, and this is like the methods we pass in through our executable, or the parameters we pass in, so don't worry about that. But here we have the code, right? Every single time I write child right here, this child just represents the variable you were using earlier, known as child PID or 0. In fact, I think it's best if I, try to replace it while you look at this. So for example, this child right here, that's just that, right? This right here is that. Let's see, this right here is that, and right there. Okay, and here we can see the exec call, right? This line right here is the exec call. Cool. And we return 0. Okay, so let's compile this, right? Let's compile this. And the way to compile it is, let's see, I wrote it down. I wrote it down right here to compile it. And I'll type this right here, paste it. And now we have the fork join. So when we write fork and join, what's going to happen? Well, it says right here, I'm the parent, so the code inside the parent process executed, and this is my process ID, and you can see that the child process ID is the one after it, right? And then we have the child process ID, and then we can also access the parent process ID. Now this is very helpful, and then the child also executed the echo command, right, from the command line. Okay, so in this video we talked about some, some more methods that we can use, like exit, wait, let's see, exec, all useful methods for executing. And if you ever wondered, right, this tool I'm using right now, the terminal that you probably have used all this time, is that when you are using this, the code for how a shell, right, this thing's actually called a shell, for how this terminal works uses forks, right? For example, you might have learned something about the ampersand. Now, in programming, the ampersand kind of means and, right? But in shell programming, or shell command line tools, right, it means you're going to put something running in the background. So, for example, there's a command called sleep 5. So what do you think this does? Well, it sleeps basically for 5 seconds, and then it comes back, right? So if I were to write sleep 5 and then run it in the background, this shell basically creates a new process and then runs sleep 5 in the background. So when I run it in the background, my prompt, which is this thing, comes back immediately. See how it comes back immediately? And then when I write something like jobs, which is another command, it shows that, oh, it's running in the background. But then after 5 seconds, it's running this process, right? My parent process is waiting for it, and then 5 seconds later, it's still running. 5 seconds later, it's done running, okay? So if you wondered, oh, well, when do people actually call this fork function? Well, here it is. This shell that you've been using all this time, right? You've probably been using this terminal tool all this time. It calls the fork function. Cool. Thanks for watching. Hope you enjoyed.